Hello, good morning, good afternoon, good evening, everyone, and welcome to Series 3, Episode 5 of Going Meta, a series on semantics, knowledge graphs, and all things AI. My name is Adam Cowley. I'm the Manager of Developer Education at Neo4j and one of the team behind GraphAcademy, our online training platform. I'm in here this week filling in for Alex, who is taking a well-earned break. And so this week we're going to talk about agent memory and decision tracing. So how do you build an AI agent that doesn't just respond in the moment, but actually learns from the decisions it makes? How do you capture not just what happened, but why it happened, the reasoning, the risk factors and the precedents? And when your AI makes a decision, how can we learn from the similar decisions that it has made in the past? So to answer these questions, I'm very pleased to introduce you to the man who has spent 9 years at Neo4j helping customers solve
Whoa,
problems.
whoa, 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 Adam! It's been 10 already, so
10 years. Oh, okay.
10
Oh,
years.
imagine.
It was 15.
Oh, wow. So
Can you
the
believe
man
that?
who's now spent 10 years helping customers solve problems with knowledge graphs and connected data, the author of O'Reilly's Knowledge Graph book, The Definitive Guide, and the man who brought together two warring communities over the vision that semantic data doesn't have to be a war between RDF and property graphs. He is a man that I've worked with on many projects so far, and now as the Neo4j's AI field CTO, he and his team help enterprises take AI systems into production. So ladies and gentlemen, I'm pleased to welcome Dr. Jesus Barassa.
Oh man, Adam, that's amazing. Really, Alex is gonna have to, improve his game. That's nothing. Like he's got too comfortable. I mean, he just say, "Hey, here we are again. Jesus, how are you?" No, that was amazing. That's a proper introduction. So yeah, no, it's really nice to be here another month, and it's good to run another webcast with you. I mean, I was trying to remember, and I don't know if I'm wrong, but probably the last time we did one was in the COVID lockdown time. Do you remember how we did a couple of them on football and stuff? But I don't know if we've had any other recently. But yeah, no. In any case, good to have you. And well, with these introductions, I'm going to want you, on a more regular basis.
Well, let's see what we can do. But yeah, no, I'm definitely pleased to be here today, and yeah, looking forward to learning a few things about agent memory, because it's something that we have covered, kind of in GraphAcademy, but we can definitely do a better job. So what I'm hoping you can do is teach me today, so I can transfer that content over to GraphAcademy over the next few weeks.
We can definitely try. So let me share my screen and tell me if everything looks all right. I'm going to share my whole screen and go as usual on over a couple of slides to give a bit of an intro to what we're going to be doing today, and then go straight into the code. So yes, like you were saying, today we're going to be talking about agent memory, and we're going to do it to introduce a new component that has just been released as a labs project. But yeah, I think it's such an interesting space, and I thought I'd mention a couple of companies are building products for precisely for that, for agentic memory on graphs, and some of those have been they're in our partner ecosystem, and they've been collaborating with us in a number of ways. They've been at some of our webcasts. We see, I mean, the three that came to mind and that I talked about in this slide are Zep with the product Graffiti, and you see the links down there. So they published on our blogs, and the central one you see Cogni, and that looks like another webcast with Alex and the CEO of Cogni, and the one to the right is Mem0. But all these just to kind of confirm this idea that there's sort of wouldn't call it consensus, but there's kind of an agreement on the fact that that storing memory as a graph is a good idea, right? And you've touched on some of the different types of memory out there, right? So in particular, the one that's becoming least for the last few months, not even months, but the last few weeks, with this whole conversation around context graphs. This idea of storing. I think it's not far from what we used to call procedural memory, right? But capturing the why, like how agents operate, why decisions are taken, which are the steps that get an agent that an agent takes to solve a problem, so that it can eventually learn from it over time, right? And so that's so yeah, starting point is, there's already, I mean, we're not starting from scratch. I mean, there's companies that have been around for quite a while that have implemented memory solutions on graphs on Neo4j. So I invite you all to have a look at these these content, and these are the links. But basically the focus today is going to be this new labs project called Neo4j Agent Memory, which is our own approach to storing memory, and it's as recent as it's 24 hours old, basically. I think this blog post was released yesterday, and it's basically the announcement of this new project. You have again the link, like all the labs projects is open source, so you'll have the link to the GitHub repository there, and Will created this blog post with a great example. So basically, what he took is the whole series of Lenny's podcasts and built a memory graph out of it, and put a nice UI on top. So you have it there on the right-hand side. I mean, we might have a look at it later, but it's again, it's a hosted solution that you can go have a look at and have the kind of the whole experience. So that's the focus today. So my plan is, well, maybe not do a super deep training, but at least kind of a 101 on what's in there, what's in these agent memory repository. Does that make sense, Adam?
Yeah, this sounds good.
Perfect. So basically, this package supports three types of memory that we've named, I think in order to simplify, because over the last few months we've talked about things like episodic memory, semantic memory, temporal memory, and I think it was a good idea to kind of make that more more user friendly. I mean, there's this idea of a short-term memory, like what's happening in the current conversation, in the current session, right? And there we work in terms of messages. That's the messages that we exchange when we interact with an agent, with an assistant. There's the longer-term memory, which is a knowledge graph. Is what are the things that we extract out of these interactions? What are the concepts that we learned and that we understand, how they relate to each other? And then in that scenario, we talk more about entities, right, and how they relate to each other. And the package introduces also the notion of preferences and even support for things like geospatial querying and all that. But this is kind of the longer, what we used to call the semantic memory, right? And the short term would be closer to the episodic one. And then the reasoning memory is this idea of the why, right? So we're going to capture these traces, like the how of how an agent operates, and then we're going to see how that's broken down in the individual steps, so that we can then find things like similar traces. So what you have there is I've taken the screen capture, but this is the core API, the set of functions that we're going to be testing. And all these, obviously, and we're going to see that in action now, are effectively backed by a Neo4j graph, right? So the combination of these three is what's going to enable these idea of a context graph, right? That has been in all the forums for the last few weeks, and I like it because this kind of makes it real, right? So we can see it in a real example. But yeah, that's the plan. So I think with that, I'm going to move to my first code, which is going to be running in a Python notebook. So hopefully you can read that. That's big enough. But before that, I've started an Aura instance, which is empty. I think I've been playing around with it, but should be empty by now. So hopefully, yeah, that there's nothing in there, so there might still be the labels because I've been, like I say, playing around and creating some indexes. But this is the Aura instance that we're going to be using for this example. So the the first section, well, it does the installation of the package, and it provides the essentially the credentials to log into this instance, right? So I provide the user, the password, and the URL to connect to this Aura instance. So I'm going to be running these, and let's start with the short-term memory. So we instantiate this memory client, which is what we're going to use. I've broken it down to make it a bit more readable, but we see how in the code might, it's more, not ideal, but it's meant to be a bit, didactic to show the kind of things that we're doing. So with short-term memory, like we were saying before, we're talking about messages, right? So in this short-term memory, what we have is the context of a session and a sequence of messages, right? So what you see here is that the main functions that we saw in the previous diagram is add message here. So we have our memory client object, and we have in the short-term section the add message function. So we identify a session with its unique identifier. In this case, I'm giving it here. I'm looking at the kind of the atomic functions that you have in this package. We'll see them afterwards used in the context of an agent, and how these actually, I would not be doing it manually, but would be the result of an actual interaction, right? But as we can see, we pass the session ID and then just the role in the content, right? So, and here, well, as a user, I'm asking for a restaurant, and then I'm simulating the fact that an assistant would respond saying, well, that's great. What's your favorite cuisine? And then I would go and say, I love Mediterranean cuisine. So if I run these 3 create add message steps, I would expect, before I do anything with them, is that and I'm going to explain why we're getting this download at the moment. But basically what's happening is this obviously synchronizing with our Neo4j instance. So we're going to see the nodes representing these messages. But it automatically is going to run entity extraction. So it's already kind of anticipating the next type of memory, which is the longer term memory. And for every message that's exchanged, we're going to have, I'm going to talk a little bit more about how entity extraction happens and gets configured in this package. But that's essentially what's happened. So if we now go to our instance, we should have 5 nodes. And if I, well, maybe this is going to give us the nicest view. Let's make this a bit bigger. But what do we have here? Well, we have a node representing the conversation, so that will be the root. Okay, and we see that it's the conversation is form of a sequence of messages. I don't know if it's readable. Make it a bit bigger, but you see that the sequence is using the next message chain, right? So each of the messages will contain the text, and it's been vectorized, and also they're all linked to the conversation node. We see that only one of them actually has produced an entity extracted. So here you see the labels that has extracted an entity that's described as Mediterranean. It's in this case geographical. I was referring to it as Mediterranean food, but this is kind of a geographical item, and it gets linked to the message through the mentions relationship. Sorry. Here we go. So that's the kind of storage, and there's obviously a pointer to which is the first message to where the chain starts. But in any case, all the messages are timestamped, so we have it. We could have worked that out anyway. So right, that's the first type of memory, right, and how that gets persisted in the graph. So what kind of things can we do with that? Well, we can. For example, we can get a particular conversation, right? Which is what we're doing with the get conversation method here. And we pass the unique identifier. And what I'm going to be doing here is printing the conversation. So effectively, what I'm going to do is find the node that represents the conversation and retrieve all the messages in sequence so that I can operate with them. In this case, I'm just going to print them. And I can also do searches, as you can see. So I can do search over the short term with the search messages, passing a term, and it will return things that are similar. So what's happening here is that this entity extraction, while this runs, is using some models. In this case, I think are being downloaded from Hugging Face, and that's what this is showing here. But yeah, so like I was saying, so get the sequence of messages from the first fragment, and then on the second one, I can get all the matching, all the similar. It's returning the whole thing, even with the embedding. So we could maybe do something like, yeah, I could actually have iterated on these to make it look nicer. That's not what I wanted to do. So for, yeah, oh, that's clever. There you go. You don't need to type anything here. So yeah, that should look nicer, the role and the, no, that's not message and role, because these are going to be, yeah, that could be. So it's some messages. So we can do the search based on a particular term, right? Yeah, probably didn't make it very clear, but obviously the last one, I mean, the first three is the sequence, looking for a restaurant, what's your favorite type of cuisine, and I love Mediterranean. And then this last one, when I search for restaurants, it only returned this last one. So it's not working here. But,
so I assume that the first query there with the get conversation is just a pure cipher query that just retrieves the messages in sequence, and then for the past messages, is that using vectors and semantic search?
Exactly. So on this one, because it's entirely deterministic, so we just would, I mean, we could actually write that query here. You can look up the conversation based on these ID, and we could. That's one of the powerful things. Oops, I'm jumping to the. But we could simulate that query. It probably is doing something like matching the conversation element. Probably there's a property that's what's it? It's session ID. So hopefully that's gonna give me the session ID equals the one that I was retrieving. And well, you can test my cipher skills here, but we're gonna get probably, I would say, would navigate the first message, right? And is it helping with the autocomplete? First, it's not message, right? So that will get us to the first message, and we can then well, do a variable length one to get all the rest, right? So the has next, so it will be next message. Next message, we would get as many as we can find all the way to the last, right? And until, well, yeah, I guess I could refine it until we would need a where. Do I need to do that to make sure that I get the whole chain? So if this is the last, I have to make sure that the last one does not have a next, right?
Yeah, that's right. Yeah, for all of your questions on Cypher, you can go to GraphAcademy to learn more about that.
Absolutely.
Pointed at you, Jesus, there.
And that's I probably shouldn't get into that, but so that will be the that will be the path, and
well, you got double quotes as well there and after session ID.
What did I miss? That session ID
on line 1.
Line 1. What did
so user 1, 2, 3. There we go.
Is that? Yes. Okay, so that should hopefully return the path. Of course, I deleted one too many. Okay, and there we get the path, and we could, for each of the nodes, but I leave it to the interested, practitioner to get for each of the nodes in this sequence, well, return the message. But that's effectively, to your question, the first one entirely deterministic. So given the ID of the conversation, I can get the sequence of messages. For the second one, it would be a vector search, and I would expect that to be based on the vectorization of this term, and then finding similar ones in across all messages. Good stuff. So that's the first type of memory, right? Like short-term memory that's based on this idea of messages. Then if we move into long-term memory, here we're talking about entities. It's more the traditional knowledge graph that we would build in any case, right? So it's built out of entities related to other entities. And in this case, well, we use a similar syntax. So we have the memory object, and we use long-term in this case, and we add entities. So we give the entity a name, and we're going to give it types and subtypes. In this case, I've taken this from the documentation. I don't exactly what individual is a subtype of person, but anyway, it basically tells you that you have 2 levels of classification to characterize the types of entities, and there's an interesting mention here. Here I'm being explicit about the entity type and the subtype, but when we use the entity extraction, which is what happened before, so here what's gonna happen when I run this is I'm explicitly going and saying, hey, create an instance of an entity of type person that has this name John Smith. I didn't have to do that when we run this, because the behind the scenes the thing when I talked about Mediterranean food, if you remember, it came out with this entity extracted in an automated fashion. So what happened there is that, and actually I'm going to go into this slide that I left. So this package has a built-in entity extraction pipeline that I'm going to just briefly mention here, that follows a number of steps. So you can configure it in a number of ways, but it would start from your raw text. It does not necessarily have to go straight to an LLM, which seems to be the default approach these days. And what it enables is for you to use things like, which can be interesting from a cost point of view, from an efficiency point of view, right? Like all the types of models. And here you can configure a Spacey or Gliner, and then have an LLM as a fallback when the certainty. I mean, what was the term? Like the accuracy. I don't think what's the can't remember the term. But when you don't have certainty that the entity has been extracted, is correct. So if you define a threshold and you think that that's below a certain threshold, you can fall back to an LLM. But this is something that you can do when you do batch import, but also applies when you're doing this kind of implicit and automated extraction out of text. And then it can be enriched and improved by doing things like merging the duplication and even enriching with external sources. So that's built into the platform. We will not go into details on that, but that's there too. So right, so this is what happened in this when I use the short-term memory, but is what I'm going to be doing when I interact with the long-term memory API explicitly. So I'm creating the same type of entity with this function, and one thing I can do when I run this entity extraction is provide a model, and the package comes with a bunch of built-in models. This Pol O is, I think Pol stands for persons, objects, locations, events, plus O, which might be organizations or something like that. But basically, you can provide the, I mean, I'm not doing it in this case, but you can do it when you configure in batch mode, which is the model that you want to apply. And this is kind of a general one, but if in the example that Will has published, it's information about podcasts, right? This Lenny series. So there's another model that contains probably entities or categories that are relevant to that space, like who's participating in that episode, what are the subjects, what are the, so it will have, instead of persons, object, location, events, it will have some entities that are relevant to that particular domain, and there's a bunch of them. I mean, actually I didn't think of bringing it here, but we can probably, I don't know if it's mentioned, but we can. So, well, I don't want to create an issue, but I want to, didn't want to do that. Anyway, I wanted to show you the GitHub repository, which I had somewhere here. I'm going to bring it.
So that is linked in the chat for anybody who is interested in trying this out as we go along.
Great. So yeah, that's so if you scroll down in the README, you will see that the poll model contains these effectively the entities that we were talking about, but there's a bunch of additional ones. Here we go. The poll one, there's a podcast, there's news, scientific, and I suppose this is a list that can be extended. But basically, passing the kind of categories that you're interested in, well, it informs the behavior of the entity extraction component, right? So it will focus on these type of entities instead of doing a blind extraction. So yeah, let's go.
So the nice thing about this as well is, especially using spaces, that you can train your own named entity recognition models, which will always give you better results than, you know, if you just try and chuck a load of text at an LLM and get the results back. You know, rather than the steps that an LLM has to go through to actually to do that, to firstly understand the problem, recognize the entities, and then even just to get a structured output back from an LLM can be difficult. Whereas that's all baked into the spacing model itself.
Totally, yeah, and that gives you. I mean, I'm not super familiar. I don't know if you work, Adam, with the Gliner and what's the difference between the two, but yeah, I was looking at it more from a performance and cost point of view, right? If we think that, you know, working with a large corpus of documents, probably sending that over the, you know, to an OpenAI model, it can be yeah, significantly expensive. So there's that.
Yeah, yeah, and the privacy side of things as well. Like the content doesn't have to leave your computer or your network. It can all stay locally, and you don't have to worry about any of those privacy concerns either.
Correct. Good. So yeah, let's try that. So we can we're gonna create an entity in this case. I mean, the API is pretty intuitive. So like I said, the type and the subtype, and you provide a description. You can also create the notion of a preference, right? So this is another type of long-term entity. It's less of a knowledge graph, you know, kind of entity relationship, but kind of an interest. And finally, there's an interesting type of item as well, which is a fact. And facts have temporal validity. So we can create a fact defined by a subject, predicate, and object, and it has a valid from and valid until, I believe is or valid to. But you can specify these type of temporal validity. So if I run this, they should give us a similar result on the Aura side. So we should now have additional entities if we push here. So we have John. That's not very readable, I guess. Let's make it a bit bigger. So this John Smith is this customer who loves the Italian food that has been embedded, and the other one was the fact. So if we look at the fact, so it stored the subject, predicate, object information, and it has the validity as a timestamp, and of course, like every other, it has got embedded. So once we have it persisted in the graph, so what we can do is we can do searches, right? Search for entities, right? So in this case, I'm doing just a simple. I mean, the graph is very poor, very small, so there's not much in it. But if I do a search for Smith, it will return the entities that are in proximity of that, and I'm returning the type and the description. So basically, the information that we had just entered here, right? Good. So these are the two basic types, and then you know, for the more interesting part, we're going to look at the reasoning memory. So this is this procedural one where we actually these I'm going to have to edit it, but again, I'm manually doing it here. But basically, these would be the steps involved in the execution of some tasks tasked by an agent, right? So what we do here is we start a trace. And then on that trace, we start adding steps, right? So, and then, you know, in the steps can include tool calls, right? And then it gets completed. So in this case, we're simulating the execution of finding a restaurant for a recommendation. And I've in this, I've done it manually. This would happen typically, but I'm passing the ID of the message. This is optional, so we can just not add it. But sometimes if this, the execution of this task is triggered by one of the messages that we have captured in the short-term memory, we can have that link, and that will enrich the graph that we create. So this is from a previous execution. What I'm going to have to do is, let's say, if this finding a restaurant recommendation, let's say it's triggered by me running this message. Well, what I would need to do, my code would need to do, is get that ID and link these two things together. So I can do it manually here. Here's the message. So I'm looking for I hope this is readable. I'm looking for a restaurant. So let's say that this message is the one that triggered that. So I'm going to capture the message ID, and like these things are going to link nicely. So I'm going to replace that code that I had from a previous run with the new one. Oh, again, it came with that's the ID, and I'm going to do it again down here. I'll link it to the same one for simplicity. But basically, this message triggers an execution of a task, which is the finding a restaurant recommendation. So here's where the trace starts. I link it to the message, and then first step is, well, sort of a reasoning step. So I should search for nearby restaurants. That's step number one, right? And then these steps will involve calling a tool in this case. So there's a tool call. I'm doing it manually, but this would be obviously configured in the context of your agent, your assistant. And the tool has the tool name. In this case, is some sort of search API, the arguments that I'm passing. So I'm looking for Italian restaurants in this case, and I'm simulating two potential results to restaurants that are returned from this API. The result of the execution, the status is success, and we can put the duration, right? And again, we'll link to the message that triggered that. So that's an optional element, but that helps then within navigation. And finally, we have the trace completion, where we return as an outcome that we recommended the trattoria one. So that's sort of a manual step-by-step description of what the task is, and a simple one. And if we run this will persist it in the graph, and we'll be able to, like we did before, to see what that looks like. Sorry. So we should have now, let's look at the reasoning trace. There we go. So that's the starting point. And if we expand, we see that, let's make this a bit bigger. I can probably hide this a bit too big. Anyway, so we have the two steps, and then the search. If we expand again, we'll see that it includes the tool call with all the information that we had before. I'm not very good at this, but I hope it's not too confusing. So we see that basically every node, in this case, the one that represents the tool call, contains all the information that we were passing before. Like the arguments is the query, Italian restaurants, and the results is the list that we show in our example, right? So that's the representation of what an execution trace looks like as a graph. Now, what can we do with that? Because, like you said, Adam, at the beginning, the reason why we do that is because this can inform future executions, right? So if we are searching, in this case, it's a very simple operation, right? But let's think of a more complex task. You want to look at the existing traces and find similar ones, right? So we can do things like call the reasoning memory and say, give me similar traces to, let's say I'm recommending restaurants. So obviously this is way too similar, but again, we're working with a relatively small data set. But what this returns is, yes, there is a match, and it was the find the restaurant recommendation that was run on that date. And that would be the starting point to finding similar executions where we could find, like you saw before, we have two calls, status like successful. Let's say in some cases it was unsuccessful, or the task completed in an unsatisfactory way. So we can learn both ways, right? We can learn this is a pattern that we could repeat again because it was successful in the past. We can even use it as a cache, right? Something like I already run before, I don't need to do it again. I mean, the response still valid. Or in the same way, if it was not satisfactory, maybe avoid taking the same approach. So that's the basic sort of API that on how we create a trace and how we can query it by looking for similar ones. Make sense?
Yeah, definitely. I think that's so important as well, because if you think of an LLM as a probabilistic, kind of next step guessing, if not next word guessing, then next step guessing. And then if you think if you're trying to get an LLM to perform the same task 100 times, in theory that could be 100 different routes that it takes to get to the end result. Whereas if you can see from some sort of feedback or some evaluation that this path was taken X number of times and it resulted in a positive outcome, that could be something that you then kind of delegate to a tool like a sub agent, which has these steps predefined in them with its own guardrails as well. So I think that's very, very interesting, really important part of evaluation of agents.
Absolutely. So that's an interesting one. So what you are suggesting is that maybe the analysis of the traces can inform the creation of specific tools, right? So this task, or in small variations of it, has been executed hundreds of times. Therefore, maybe it deserves. That's a very, very interesting, because there's obviously the explainability, the traceability element, which by definition is built into that. So you know exactly which steps and why they were taken. But this is another very interesting point too.
Yeah, definitely. And I can see as well, like the tool called status success in the status there. I think that's an interesting one as well, because that's an easy way, especially with like the lineage of the messages and the trace, that an LLM or an agent, some provider will. I literally had the experience today where I wanted to generate something, and then there was a tool call in there that was, okay, go away and get a transcript and then generate the summary from there. I think in this case it was like, get the transcript of a conversation so you can understand the way that the person speaks. And the actual tool call failed, and then it went through and just hallucinated something based on its own patterns.
Right.
And that's like a really important thing to find in there as well, because the thing is clearly hallucinated, and it's not done what it's supposed to, because that actual tool call failed.
Yeah, very good point. So that actually there's I'm not going anywhere near, but there's a whole section on built-in. Let's see which, but there's you can analyze traces and you can filter traces. So I really definitely encourage people to go beyond what we're the basics that we're covering today. But there's a lot of great features built into this package, and that will help you in this direction, right? Like analyzing traces and doing some observability, and which is one of the core values of the whole point of adding agentic memory. So, and then another very important point: integration with other frameworks, which is also built into this initial release. That's a very interesting point. Good, but let's complete the example, because I was going to show how we can do things like conversation summaries, which is another interesting feature. So now we're going back to the it's a combination between the short-term and long-term memory, but the starting point is a conversation ID. So my intention here is to produce a conversation summary, right? So I call this primitive in the API, get conversation summary, by passing the ID like we did before. And it will retrieve the messages, it will retrieve the entities that have been extracted, and it will produce, in this case, return it as a structure that we can then customize by passing it, for example, in this case, to an LLM, and asking it to summarize a conversation concisely based on the content that we extract. So if I run that, and hopefully I've configured my, there you go. So if you see, the first print is the summary, the summary field. But basically, it tells me that there's a conversation. It's a simple one with 3 messages, 2 from the user, 1 from the assistant. It started by me asking for a restaurant, and the key entities was just Mediterranean food. But what I've done is, by invoking this summarizer LLM base using GPT-4o Mini, I've not been great at naming things, but yeah, it's created these kind of more human readable, more nicer text telling us that the user is looking for a restaurant and expresses a preference for Mediterranean cuisine. So again, simple example, but it's a feature that's built into the package, which is very, very convenient. Good. And what else do we have here? I think that's pretty much it. I think this is leftovers from previous executions. So I'm gonna stop here, because we kind of have covered the three main types of memory. And what I'm going to try to show, and it's an example that's in the repository. It was a bit incomplete. I think I got the impression that it was built on a previous version, so I've tried to adjust it to this one. But the example, and it's here in this section, it shows the basic usage of memory in the context of an assistant, right? So that's what I'm going to be running. So like I say, if you run this, it won't work out of the box, but with some small changes, I've got it to run partially. But this gives us a little bit of a clearer idea of what the experience is like. Let me actually empty the database before we get started, so we don't get confused here with all the previous executions. So I'm going to do a match and catch deleted. So there you go. So we should have an empty database now. We can get rid of all these elements. And if we go to the code, again, this is in the GitHub repo, so feel free to go and analyze it in detail. But effectively, what it does is it creates kind of an assistant that helps us, going through the process of purchasing some sports equipment or purchasing in general. I think some clothing, I can't remember. But it has built in the management of the memory. And if I started the assistant, it should, and we can see what's it doing. So it's your name, Jesus Barraza. It starts a session. So I would expect that to be, unsurprisingly, a session created in the graph. And we have also at any time the opportunity to finish the conversation or to check what's been stored in memory. So what I'm going to do is hi, I love football and I support Real Madrid. There you go. So I'm starting to give it some information about myself, because what's going to happen, and again, there's this kind of built-in entity extraction. I haven't found how to hide or make this less verbose, but it's, in this case, I think it's downloading some Hugging Face messages. But anyway, quick check on the graph side. Let's go to our, so we should start seeing, here we go. Let's make these a bit bigger. So first step, we'll have like before, in short-term memory, you have a new conversation with the identifier, and when was it updated? And the first message is me saying, hey, I love football and I'm a Real Madrid supporter. So the entity extraction has extracted an entity which is football, Real Madrid as an organization, and Real Madrid also as a facility or location. So I've not been able to configure here and pass kind of a schema, kind of an ontology in a way. So it's probably going with something like the poll model by default. So that's not ideal, but anyway, that's just shows the behavior. So all this to say that in the context of this sort of chat, a conversational experience where I'm talking to an assistant, he's saying, hey, that's awesome. Remedy has such a rich history, blah, blah, blah. Are you looking for any specific types of shoes? Well, I'm going to say, well, I'm looking to buy a football kit. And like this, it keeps building steps in the conversation. So we should be seeing, if I expand the response by the agent, by the assistant, I suppose these as we go will get linked and the graph will grow as we go. We already have the answer. They've extracted a new entity, which is football kit. Great choice, which is probably the response that we're getting here. There we go. Great choice, since you're a Remedy fan, whatever, blah, blah, blah. I'm going to say, I can go in here. I was looking for an Italian club kit. And anyway, so the example is obviously simple, but this shows more the kind of the built-in experience that we would normally see, which is the memory being built as we interact with the agent. Unfortunately, I've not been able to to get to the point where I could also create the procedural memory, the trace. But you can see the idea, right? So it would be pretty much the same thing, but it would be invoking the primitives that we were seeing before. So anyway, so we have we can keep expanding it. We have the new steps. So every time there's a new message, we'll see the graph growing. Normally, this would be linked to the previous one, and the entity extraction keeps happening as we go. So I'll pause it here in the interest of time, and like we can say at any time things like memory, and it will give us a summary of what the agent knows about us. So the recent conversation, it will give you the episodic memory, the short-term memory here, and basically tell us the entities that it's aware of. So that's kind of the more real implementation of memory in action in the context of an assistant like this one. So let's take a pause here. I think that kind of has covered the basics of the package, and yeah, maybe we can take any questions if there's any in the chat, or any that you may have, Adam.
Yeah, it's really. I mean, I have many questions. So for anybody that's watching along, the link to the repository is in the chat. So feel free to play around there. There was a question as well around will the presentation be recorded, and can we access it later on? I've been trying to post a message back on LinkedIn, but I can't seem to do that. But yes, all of the sessions are recorded and put up onto YouTube. So if you go to youtube.com/Neo4j, you can catch this and all of the other episodes of both Go and Meta, and all of the other live streams that we run as well. If you want to leave and rejoin the session, then that's absolutely fine. The one question that I have is, and I'm going to put you on the spot here.
Yeah, let's.
So let's say two questions really. At what point does the entity extraction from these messages become a knowledge graph?
That's such a good question, because I was actually looking at the example that Will has published, right? The Lenny podcast. So yeah, this is processing messages. It's but yeah, I mean, let's so what's the difference between, when is a knowledge graph memory, long-term memory, or when is it data? When is there a difference? I mean, I think there's not like a line that tells this is. I mean, in the end, as long as you track provenance, I mean, maybe yes. I mean, in certain types of projects, it's important if the information comes from certain sources and in terms of explainability, provenance, and but I think I don't know if your question was in that direction. Like, what is memory? What is knowledge graph? What is data? When am I just retrieving data? When am I accessing my memory? To me, it's kind of a blurred line. I mean, it's very, very similar, because ultimately you're retrieving information. Some of that comes from maybe a source that you are not in control of, because it's a CRM system, because it's a catalog, because it's or maybe it's the result of your execution and your interaction with an agent, and it's this idea of a long-term memory. So to me, there's, I don't have an answer to tell you this is that or this is this other thing. So but yeah, that's a very good. What do you think? What is there a clear line? I mean, I don't know.
Yeah, I mean, acting as the host, I can't really have an opinion on this one, I'm afraid. But no, I think it's very interesting as well. And when does short-term memory become long-term memory, and that extraction of the long-term memory, is that something you want to keep as something that's just scoped to the conversation, or is it something that you want to take further than that? So, for example, on GraphAcademy, we have a learning assistant, a chatbot that we have embedded into the course experience. And if a user asks a question about a lesson, is that just something that is just scoped to that lesson, that user in that time in that lesson, or is that something that can be used to improve the experience?
New knowledge, right? Is something that can be useful for others, right? So because
yeah, definitely. I would say that if we're extracting the kind of conversation history from the kind of knowledge graph that we have, we have the full kind of course catalog, every single lesson in the database as our knowledge graph, and we also have user contributed feedback to that. So every single piece of feedback that comes in is kind of stored there, and then we use that to improve the experience. Was it hard to follow? Was there technical issues with the content, that kind of thing? And one of the things that we've done with the GraphAcademy Learning Assistant is that we've given tools to the LLM to the agent, and the underlying LLM chooses to call them or not. When the user is talking about frustration or the content, then we can store the feedback in the database, and that's then promoting from the kind of short-term frustration of the user into something that goes into our domain graph. But yeah, it's an interesting debate to have, I suppose.
Totally. Yeah. And the other question you had too, or was it?
So I suppose that the other one is, maybe you've answered already. Maybe it's just a cheeky one, but what is the difference between a context graph and a knowledge graph?
Yeah, well, yeah, I think there's been so much debate on that, and in the end, is ultimately a terminology thing. I mean, as long as you can, because we've said that probably in this idea of short-term memory, long-term memory reasoning, probably these long-term is the closer to what we refer to as a knowledge graph. Why? Because a knowledge graph is described in terms of entities, relationship between them, etc., etc. But I'm not a big fan of kind of creating. I know some people get a bit religious about that, and is the reasoning not part of the knowledge graph? Well, maybe it's just an extension to it, right? Because as we've seen, I mean, all these graphs are interconnected with each other. So these entities are mentioned in conversations as part of messages. These messages also trigger reasoning. The reasoning might refer to entities. So I like to think of a graph rather than what's context towards what's knowledge, what's I'm yeah, I wouldn't try to kind of put a kind of a line. To me, yeah, it's true that in general we tend to focus on the what, as in a knowledge graph, as in this is what's true, but extending it with these why, with how these became what is, why this license was sold with this discount. I mean, I can see the discount, but what was the process, and what, in the context of an agent like we've seen, is relatively, since it's an automated system, you can persist those individual steps and the exceptions that were made, or the analogies, or the reasoning that took place. In a real world context is much harder, right? So when these conversations happen on Slack, or happen over emails, or happen through many different channels, so yeah, to me is all part of the same graph. It covers an angle that often knowledge graphs tend to not focus on. But I'm not going to be one that tells, hey, sorry, this is not this, or this is not that. That's the question is whether it's useful or not, right? And whether it helps you doing things better. So that's the
yeah. And I suppose the classic answer is, like, as us two as consultants, it depends.
Depends, of course.
Yeah, I think that's the benefit there of having a graph database back in your AI application, is having the ability to say, having this kind of this Venn diagram in the intersect of the context graph and the knowledge graph, is the information from the knowledge graph that helped you to answer that question in that context. And then for explainability purposes, you can say, okay, well, we know that this fact that was used in the in the context graph, in the context that allowed us to answer the question, is this fact. This fact, we can link it to this document, to this source, and then it provides that kind of end-to-end explainability.
Yeah, and it looks like in this diagram, as you can see, it seems to suggest that the context graph is the sum of all these parts. I mean, so maybe it's kind of a wider term, but yeah, the more graphs, the more connected, the more paths for exploration, and the richer types of analysis that you can carry out. So yeah.
Definitely. Cool. Brilliant. So we are almost at time. So I think we should leave it there. So in the spirit of this episode, and I'm a huge fan of Lenny's podcast. I listen to it every week. Sometimes I listen to them twice. So the way I'm going to sign off the way that Lenny signs off with, Jesus, where can people find you, and how can they be useful to you?
That's great. So, well, I'm every month at these webcasts, but probably the best is to do it through LinkedIn. LinkedIn is probably the place where the conversations take place. I've become a lot less active on Twitter, X, these days, so probably LinkedIn would be my recommendation. So.
Perfect, great. And just a short plug for Neo4j GraphAcademy, our online training platform. This is I share my screen. This is my day job is running GraphAcademy. So our job is to use generative AI and knowledge graphs to teach you about knowledge graphs and generative AI. So we have courses that give Neo4j users from beginner to expert hopefully everything they need to be successful with Neo4j. So we start off with fundamentals courses, the things that we believe that everyone needs to know. And then we branch off into different subject areas. If, like me, you are interested in generative AI, then we have a learning path for learning Neo4j and generative AI topics, including graphrag, all the way from the fundamentals through building a knowledge graph to actually applying that to your project. And also need to call out that we have Nodes AI, our AI version of or AI flavor of our online conference, coming up in. I should know the time of this one, the date and time.
April.
Yeah, so April the 15th, 2026. So it's going to be I think there's 3 tracks. So there's sessions from some great speakers, including Will Lyon, who is the author of the package that we've gone over today. But yeah, thanks everybody for joining. Appreciate you taking the time to talk with us, and yeah, we'll see you soon.
Thank you.